First Spin. Welcome to First Spin, a show where I learn how to use the parallax propeller without having any prior programming experience. And rather than do this on my own, I have enlisted the help of two expertisos.
I'm Whisker.
I'm Roy.
And technically, I think we know more than Addie, so she roped us into this.
Did I?
Yep.
Although I don't know if I like being called an expertiso.
Well, you didn't want to be called an expert. So, expertiso. Like, awesomeo. We're off our rocker today. So, we are talking about directives, right? And I'm sure there is some sort of Star Trek
explain directives
joke about this.
Are we really that far along that you're making us explain directives?
Prime directives.
What was the prime directive?
Nerd joke.
No, I know, but
It was from Star Trek.
right. I knew it was from Star Trek.
They shouldn't interfere with lesser technology races.
Ah, you're correct.
Anyway.
Right, directives.
Before you guys get too far into your directives there, I just wanted to say thank you to all the awesome comments we've been getting
Thank you.
on First Spin.
Yeah.
They're very nice.
And
very
Parallax
nice and
forums and whatnot.
Yes.
Yeah. We're glad you guys enjoy the show.
Yes, we are glad you guys enjoy the show.
All right.
What Whisker said.
Yeah. So we're going to change directives again. And
Direction.
oh, yeah.
Let's direct our attention to
directives.
the directives.
What do you want to know about directives?
Well, what are they?
So an example directive is the string directive,
Oh my.
which you could use to create a string constant in your code.
Now you're just putting
Yeah.
two words together.
So say you wanted to send a string to the serial terminal, right? Which I believe you've already done.
Okay. So for the super noobs, strings are like letters, like a string of letters put together. So
Each letter being a byte.
right. So if you want to send
Or
a
a
message
char-
like hello world is a string. Right?
Yes,
Right.
the array of characters that make up hello world is called a string.
Right.
Yes.
Okay. Just for
And-
those who didn't know what a string was.
And if you want to have one way to have a string constant in your code is to use the string directive. And the string directive is, string open parentheses, and then you put your hello world in quotes,
Mm-hmm.
and then close parentheses,
Mm-hmm.
and that declares that as a string in the code. And when you pass that into a function,
Mm-hmm.
say the parallax serial terminals str function, it will get the address of that character string that's inside that string directive
I have a question.
and be able to use that string.
Okay. I have a question. That makes sense.
Mhm.
But I was wondering, what if you didn't designate it as a string? What if you just said, quote, hello world, quote? What would happen?
Well, in Spin, in just the regular code out there, it wouldn't work. You'd either get a syntax error or you would just get
Oh.
the first couple characters as a number. It just doesn't.
Like a hexadecimal number?
No. You can do like a single character in quotes, and that is the same as if you were to take the ASCII value of that character,
Oh, I see.
and you can just apply that to a variable. So you could assign, my variable colon equals quote a quote, and then the a would be assigned into the value that's the ASCII value for a would get assigned into.
Brian and I have both been doing that a lot the last few days, but we can't say why.
Secret. Hush, hush.
Yeah.
I see.
So when you want to do a string, the most common way is to use the string directive. You
Mm-hmm.
can also do a string of characters in the dat section
Mm-hmm.
of your code. Um, and it's done just with the quote, like you said, but you do, you create a, a byte entry in your dat, and then you can put a quoted string after it. And then the label that you put next to that is how you would refer to that string. So if you wanted, like, you could have.
I actually have that up on my screen. So here,
Mhm.
Addie, you can see in the dat section we've got text string and byte, and then quotes and a bunch of text
Mm-hmm.
all the way out to the end until it hits the end quote.
Mm-hmm.
And then up here in the code, note that's the name of the variable, if you will, in the dat section.
Mm-hmm.
Up here in the actual code, we just use an @ symbol to point at it. It's a pointer
Oh,
and the name.
I see.
And then you can just pass that into the .str of the serial object.
Oh, I see. So it's like a pointer.
Yep.
Right.
I see.
Very handy.
And the difference, the main difference with those two ways of doing it is the second one inside the dat section, you can actually modify that string with code
Right.
to change what it's saying or to cut it off or whatever. When you have string in the string directive, it's a string constant. So it doesn't change. It's used for literal strings that you don't want to, that you just want to send hello world or something like that, and you're not wanting to edit the string in place.
So within a program, you can edit that string if it's in the dat section.
If it's in the dat section, you can use that at
Oh.
label like he did for passing into the stir. You could use that and pass it into something else that could manipulate the string.
So then what happens if, say, you're manipulating the string, but the amount of space that you've allocated that, like dat block, for instance,
Mhm.
is not adequate? What happens?
You get undefined results because
Oh.
you've gone outside of the range of what you've allocated.
Oh.
And typically, what that you'll end up either stomping, what we call stomping or smashing code that is after that string in memory,
Okay.
or the stack, which might be at the end of your program, if that string happens to be at the end of your program. So you have to be careful not to go
I'm
outside
sure
of the
Addie
range.
doesn't understand what the stack is. But
Sorry.
yeah. So if you remember, we talked about this before. Your spin interpreter is running in the hub memory.
Yeah.
The cog memory, rather.
Cog 0.
Right.
Yeah.
So if you overrun something in there, you're actually overrunning the code that's in there. And in hub memory, I'm not sure, Roy. Is it possible to overrun in hub memory as well?
Oh yeah, yeah. Well, if you're accessing it from spin, then it's in hub memory. So the dat section, when you access it from spin, you're actually accessing the hub memory copy of it.
Okay.
So if you overwrite past the end of it, you're going to be writing over the top of something else that's stored after it, right?
Right.
But it won't permanently damage the data, will it?
Yeah. You've overwritten the data that was there with something
Well,
else.
Well, so
it's
then
not permanent. It's just for that time that you're running your code. If you were to re-download the code from the host computer, then it would fix it. But in the that session of running, if you modify the string and you go past the end,
Mhm.
and you change some code that happens to be after that string, that code will stay changed. And if you tried to run, call that code, it would fail. It
Okay.
wouldn't do what you expected.
Gotcha.
Now, in the
Hmm.
cog side of this with PASM, you do this sort of thing on purpose sometimes because you want to rewrite your code while it's running
Mm-hmm.
so
Right.
that it can change how it's working as it's working.
Right.
And that's called polymorphism.
I see.
Right. And it's a advanced one of the things that is really nice about PASM is that it actually has stuff built into it for doing self-modifying code.
Mm-hmm. Well, because I mean,
But that gets, that gets into more advanced stuff that we're really not going to cover because we're talking about spin and not PASM for the most part.
Right. So, like, okay, so say we have a string. Can a string be a value, like a numeric value, or is that some other type of constant?
Well, you have integers or you have longs and bytes and words that can be values that are integers or floating points or whatever. But in a string, you could have a number that's in the string as a string, right? You could write into a string the number 10,
Mm-hmm.
but it would be the characters 1 and 0 in string format. You would have to convert it out of that back into a number if you wanted to do
Like math with it.
math with it.
Oh,
right?
I see. Okay.
So normally you don't do that. What you normally do is you just do all your math with longs, right? And then just have your text messages be in strings, and then you do things like print the string and then print your number and then print a new string and then print another number, right?
Right.
Putting numbers in there is kind of strange for you to do that.
Yeah.
It's not something that you would normally want to do.
Well, I'm just thinking, like, in a calculator, how it has memory. When you press the M plus, it like stores that.
You would probably use longs, to store.
Yeah, you could just have another variable that's in another location in memory that holds the stored value.
That's true.
Because when you're dealing with numbers in a string, they're usually base 256 numbers. You're looking at it as a space is a 32 in ASCII, right?
Mm-hmm.
So if you're doing math with strings, you're using the ASCII value of that character to do your math, right? And that's how like a lot of networking protocols work. So when you're getting into passing dense data over a serial connection, you'll do stuff like that. But you wouldn't write your number out with the characters for all of the numbers. You just use base 256 because you can represent any number from whatever to whatever in just a couple of bytes of it, rather than having to type it out in characters the whole length of it. It's just an inefficient use because the computer's so good at this kind of thing.
Right. Okay, that makes a bit more sense. Okay, so then string, now constant.
Now constant is a little different. You could
it's not different, Roy. Eddie constantly asking questions.
That's true. It is a constant.
Har Whisker. You're just full of good lines today.
What would this show be without my awesome puns?
So imagine you have some math in your spin program, like 10 divided by 2 plus 5. Obviously that could be reduced trivially by your head and just reduced down to the number that it is.
Right.
But in spin, when it goes to compile that, it's going to actually compile 10 and then divided by and then 2 and then plus and 5.
It's pretty inefficient.
So it's actually going to output byte codes for each of those operations, even though the result is always the same.
Yeah.
What you can do with constant is if you wrapped that expression with constant open parentheses 10 divided by 2 plus 5 and then close parenthesis, what it would do is it would compile it down to the result, which is 10 in this case, and just output 10 and just output 10 into the compiled code.
Okay.
So it's like a optimization for the compiled result, but it allows you to leave the math there in your code so that it's easier to edit.
Reference. Okay.
Well, so you can reference it or it's easier to edit. Obviously, I gave sort of a trivial, meaningless example, but if you had something more meaningful in your math,
you had to always add 12 to something, but the something that you always want to add 12 to is something that you're playing with, and you're going to dial it around as you're working on your program.
So then do you this constant, is it the equivalent of the constant section in spin code, or is it you have to write constant?
No, this is something
x equals 10 divided by 2
like that
plus 5.
This is a compiler directive. Okay.
Oh.
And Roy just finished porting the compiler over to C++.
Yeah.
And this is one of the things that I'm sure he had to figure out how to replicate. Is it goes through the code, it finds this constant statement, and at compile time, whatever you're throwing inside of that constant, it's going to bake it down to the literal simplest thing.
Yeah.
Right.
So how would you write it?
So it has what goes inside the constant directive, the parentheses, has to be all numbers. There can't be any variables.
Oh.
So it's all just, 10 divided by 2 plus 5 is all constant numbers. Like they're all just numbers that you typed in.
And here's an example on my screen, Eddie. It's just constant, parenthesis,
x minus 200.
Well, this is using a variables, and I'm not quite sure why. Maybe they're demonstrating what you can't do.
I'm slightly confused. So I understand that constant would be representing numbers.
It looks like you can use a variable name if it's defined in the con block, because that's just a real number.
Yeah, cons aren't variables; they are constants. So the x in that case is actually in the con section, defined as x equals 500. So technically x isn't a variable. It's always 500 when you compile the program.
Right.
So it's the same as saying constant 500 plus 200. Right?
No, what do you mean?
Well,
where it says constant x plus 200.
Oh.
We're looking at page 92 in the manual, by the way. So up here in the con block we have x equals 500.
Yeah.
And now that x is always equal 500
right,
no matter where in the program we are.
Yeah.
Which means that you can actually use it inside of the little constant command here as a number. So you've got constant parenthesis x plus 200 close parenthesis. So when the compiler goes to figure this out, it's going to go 500 plus 200, and it's just going to use that number here instead of all of the code to set it all up.
Why wouldn't you just say the actual number?
Speed. Well, if you want this to be something that the users can change when they're getting ready to load it up into their prop.
Oh.
Right? Like a pin number or something like that. Something that should be user configurable. You would have that defined up in the con block, and then the code is just designed below to automatically correct itself for whatever number they're plugging into that.
Right. So the key thing here is I think we're just sort of reiterating back to something we covered quite a while ago, which is the con section of your code is constants.
Yeah.
They allow you to label a number to equal some friendly label.
Right.
So like in this case, they're saying x equals 500. It means that every place where you put an x down in the code, it'll replace it with the 500.
Right.
You could also have a var section with variables and you could have a long x, right? And in that case, x is a variable and it's not a constant, so you couldn't use x inside of the constant directive in that case. But because x is from the con section, you can use it in this case. That's on page 92.
Okay.
So do you follow that, or are you still a little confused?
I'm still a little confused, but I'm okay with that.
On what?
Which part are you confused with? It's important to get this right.
Well, when would I use it?
Well,
I guess I still don't understand when I would use it.
So let's try a different example. So you have your heart LED blinking program, right?
Yeah.
Let's say that in your con section you had a value heart rate equals 120.
Yeah.
120 is a really high heart rate, but whatever.
Whatever, yeah.
Say now, and then down in the code.
That's a slow day for me.
And down in the code, you would use the heart rate label, right, to equal 120. but it still says heart rate down in the code,
right,
where you do your weight count, heart rate times whatever values that you have in there to get it to weight the appropriate amount to simulate blinking at 120 beats per minute.
Yeah.
Right. But then at the top of the program, you have heart rate equals 120. Well, you could change that to heart rate equals 80, and you don't have to change all the rest of the code. But because you use heart rate down in the code all over the place, it will, when you recompile it, it will do the appropriate math to work out to being 80 beats per minute instead.
So, okay, this is the problem, I guess. I understand what happens when constants are used in the constant section. When you say buddy equals 1 or dog equals 3. Like, I get
Right.
that. That makes sense to me. But actually using constant in the program, like as a command,
It's all about saving.
That I don't get.
It's all about saving efficiency in how your code is actually going to compile and run. So if you don't use constant in your actual code, every single time it goes around your loop, it has to do the math on all of those things.
Yeah.
If you use constant, it figures out all of that math when it goes through on the compiler, and it uses literal numbers in it when it puts it onto the propeller.
So it's a matter of speed.
Yes.
Well, it's two things. So one thing, just so you understand, you don't have to use constant. Your code will work without using the word constant to condense the stuff. One of the things that it will do is make the code a little bit smaller, because it will take instead of having to put in the bytecodes when it's compiling to do each individual math operation,
it'll have the simplified ones already.
It'll simplify it all the way down to just a single constant number. And so it's only one code that it has to put in and so it'll shrink the program size down a little bit, which could help if you have a really large spin program.
I see.
You're running out of memory. You could use constant to reduce some of the code down to save space.
I see.
It will have the side effect of also being slightly faster because it doesn't have to go through those bytecodes and do the math.
Right, it already has it.
Because it already has the end result.
I see. Okay, I get it now.
And it's just, again, the limitation is that it has to only use constant numbers. It can't use anything from a var section or local variables in a pub.
I think Roy is from the var section.
I am pretty variable.
Well, let's float on over to the next. Float. I know we talked about this earlier with floating math and like decimal points and blah blah blah.
I tried to use this command once. I failed hard.
So the float, round, and trunc commands are sort of all interrelated.
Okay.
And we kind of talked about them a little bit before. In spin, you can only do natively, you can only do floating point stuff at compile time.
Oh,
and
okay.
Usually it's used in your con section, but you can have it, you can have these directives out in your code. And as long as the end result after you've done your math with them results in an integer at compile time, then it will work out. So it allows you to do something like, 100 times 0.5, right? 0.5, which is the same thing as dividing by 2, I know. But if you do that and you have it in the con section of your spin code, then at compile time, it will do the floating point math and have a result that's 50 and assign it to whatever label you had in your con section. And then you can use that in your code. And the float, round, and trunc directives just allow you to do shortcuts to get it to be an integer for one.
Oh, I see.
For round and trunc, you're rounding it to an integer, and trunc, you're truncating it to an integer.
Right.
And so that, right. So trunc just chops off everything after the decimal point and ignores it, whereas round rounds the number to the nearest whole integer.
I see.
Right. The float directive is a little bit more special in that it allows you to declare something as a float. And really, that's only useful if you're going to then use the floating point objects that are available that allow you to actually do floating point math at runtime.
Mm-hmm.
They actually have some built in, some not built in, but they deliver them with the propeller tool, some libraries that you can include in your program and then do floating point math. And they actually implement all the multiply and divide and everything with floating point numbers. And the way you get it to something to be a float in one of your variables is to use the float directive.
Command, sure.
So you would say, float some floating point value, and that would actually get assigned into your long variable if you did like colon equals.
So float x parentheses colon equals 6. So, or 6.36 or something.
Well, it'd be more like x colon equals float, open parentheses, some floating point expression, close parentheses.
Oh. And then wherever x was, it would substitute that.
Right. So if you look at, if you go down to page 109, they have some interesting examples of using float.
109.
This one is a really simplified one, but at least gives you an idea of how you could see it.
I see.
So what they're doing there is they have one constant that equals 2, and then they're saying convert that 2 into a float and divide it by 5, and you'll get a result that's 0.25.
Mm-hmm.
Whatever. 0.1. It's 1. No, 1 over 5. Sorry, 1/5. Anyway, whatever. I'm tired. My math is. I'm reading
wrong. His math is wrong.
It is wrong. It's 2/5.
Our brains are floating away.
So anyway, what will happen is that the constant ratio will equal 2 over 5.
I see.
In floating point. So float allows you to turn an integer into a float for doing math operations. Now, ratio is if you were to use ratio down in the code, and it wasn't with the floating point object, then you probably aren't going to get the result you expect.
Mm-hmm. Nope.
Because
and that's where I failed.
What was that?
And that's where I failed when I was trying to do something because, well, propeller just doesn't do that.
Right. So by default, spin and the propeller don't do floating point math. And so the number that you would have in ratio is actually encoded in what they call IEEE format, IEEE 754 format.
Mm-hmm.
And it's a way to represent floating point numbers in 32 bits of space. And it's beyond our scope of our show to go through explaining all that stuff, but people can look up that IEEE 754 standard.
Sure.
And read about it.
Yep.
But,
so there are ways to do floats, and there's also, I think, an object up in the exchange that can help with
note
doing
to self,
floats.
Use integers.
Yeah, if you can, use integers because, computers like integers. You could go absolutely crazy and use Addy's trick there with putting numbers in strings and creating your own code to do floating point math longhand. It would be very, very slow, though.
Yeah. And I mean, the float math and float 32 and whatnot that come with the prop tool allow you to do floating point math at runtime. It's just a little more work and it's a little slow, but it can be useful for certain applications.
Cool.
All right. That's all the time we have for this week.
Can you believe it?
Thanks for listening, everyone. Eddie, I hope you learned something.
Crazy directives, I tell you what.
We'll be continuing with directives next week. I think we only have file left, and then we're going to be getting into some really interesting stuff. All right. You can find this show every Tuesday at firstspin.tv, and you can follow us on Twitter at TYMKRS. See you guys next week.
Bye.
Bye.
Later.